Space is incredibly vast. It's a realm that stretches beyond our wildest imaginations, a seemingly infinite expanse that holds countless mysteries and wonders. It's hard to even imagine how big it truly is. When we look up at the night sky, we see just a tiny fraction of the universe, a mere glimpse of the vastness that lies beyond. Our own galaxy, the Milky Way, contains billions upon billions of stars. Each of these stars could potentially have their own planetary systems, much like our own solar system. And if that's not amazing enough, there are billions of galaxies out there just like ours. Each galaxy is a massive collection of stars, planets, and other celestial objects, all bound together by gravity. Each one is a swirling collection of stars, gas, dust, and maybe even planets. These galaxies come in various shapes and sizes, from spiral galaxies like our Milky Way to elliptical and irregular galaxies. We live on a planet called Earth, orbiting a star we call the Sun. Our Sun is just one of the billions of stars in the Milky Way, but to us, it is the most important star, providing the energy and light that sustains life on our planet. Our Sun, along with its 8 planets and countless smaller objects, make up our solar system. Each planet has its own unique characteristics and features, from the scorching surface of Mercury to the icy rings of Saturn. But have you ever wondered where our solar system came from? How did this intricate system of planets, moons, and other celestial bodies come into existence? How did it all begin? The story of our solar system's formation is a tale of cosmic events and processes that span billions of years. Billions of years ago, our solar system was just a giant cloud of gas and dust floating in the vastness of space. This cloud, known as a molecular cloud, was the raw material from which everything in our solar system would eventually form. This cloud, called a molecular cloud, was the birthplace of everything we know and love. Over time, gravity caused the cloud to collapse and condense, forming a spinning disk of material. It's where our story began. Within this spinning disk, particles of dust and gas began to stick together, forming clumps that would eventually grow into planets, moons, and other celestial bodies. Everything we see around us, from the ground beneath our feet to the stars in the night sky, was once part of this incredible cloud. The atoms that make up our bodies, the air we breathe, and the water we drink all originated from this cosmic nursery. It's awe-inspiring to think about the journey these atoms have taken, from a cloud of gas and dust to becoming part of us. The story of our solar system is a testament to the incredible processes that shape the universe, reminding us of our connection to the cosmos and the wonders that lie beyond. Imagine that giant cloud of gas and dust we talked about. This vast expanse, known as a nebula, is a stellar nursery where stars are born. It's a chaotic and beautiful place, filled with the raw materials needed to create new stars. Now, imagine something giving it a little push. This push could come from a variety of sources. Perhaps a nearby star exploded in a supernova, sending shockwaves through the nebula. Or maybe a dense clump of matter within the cloud started to exert its own gravitational pull. Maybe a star exploded nearby, or a dense clump of matter formed within the cloud. These events are not uncommon in the life cycle of stars and can set off a chain reaction that leads to the birth of new stars. Whatever the reason, this push caused the cloud to start collapsing in on itself. As gravity took over, the cloud's own mass began to pull it inward, causing it to shrink and condense. As the cloud collapsed, it began to spin faster and faster, just like a spinning ice skater pulling in their arms. This increase in rotation is due to the conservation of angular momentum, a fundamental principle of physics. This spinning motion caused the cloud to flatten into a spinning disk, with most of the material clumping together in the center. This disk, known as a protoplanetary disk, is where planets, moons, and other celestial bodies will eventually form. Over millions of years, this central clump grew hotter and denser. The immense pressure and heat at the core of this clump were building up, setting the stage for something extraordinary. The pressure and heat at the center became so intense that hydrogen atoms started to fuse together, creating helium and releasing an enormous amount of energy. This process is known as nuclear fusion, and it's the same process that powers our sun today. This process, called nuclear fusion, marked the birth of our sun. The energy released from fusion caused the new star to shine brightly, illuminating the surrounding disk of gas and dust. At this stage, the Sun was still a young star, not yet as bright or stable as it is today. It was in a phase known as the T Tauri phase, characterized by strong stellar winds and variability in brightness. But it was already the most powerful object in our solar system, bathing the surrounding disk in light and heat. This energy began to drive away the remaining gas and dust, clearing the way for the formation of planets and other celestial bodies. The birth of our Sun was a monumental event, setting the stage for the development of our entire solar system. The Sun is a giant ball of gas, mostly hydrogen and helium. It's a massive, glowing sphere that dominates our solar system, providing the essential energy that sustains life on Earth. It's hard to imagine how something so big and powerful can exist, but it all comes down to a process called nuclear fusion. This process is the very heart of the Sun's immense power and brilliance. Deep inside the Sun's core, the pressure and temperature are unimaginable. The core is a seething cauldron of energy, where temperatures soar to around 15 million degrees Celsius, and pressures are over 200 billion times the atmospheric pressure on Earth. It's so hot that atoms, the tiny building blocks of matter, are moving around incredibly fast. These atoms are in a state of constant, high-energy motion, colliding with each other at incredible speeds. Under these extreme conditions, hydrogen atoms collide with such force that they fuse together, creating helium. This fusion process is not just a simple combination. It involves overcoming the repulsive forces between positively charged protons. This fusion process releases an incredible amount of energy, which travels outward from the Sun's core, eventually escaping into space as light and heat. This energy radiates through the layers of the Sun, taking thousands of years to reach the surface before it bursts forth into the solar system. This energy is what makes the Sun shine and provides the light and warmth that sustains life on Earth. Without this continuous output of energy, our planet would be a cold, lifeless rock floating in space. Nuclear fusion is like the Sun's heartbeat, constantly powering our star and making life in our solar system possible. It's a delicate balance of forces, a cosmic dance that has been ongoing for billions of years. It's a process that's been going on for billions of years and will continue for billions more. As the Sun ages, the fusion process will evolve, eventually leading to the Sun's transformation into a red giant and ultimately a white dwarf. But for now, we can marvel at the incredible power of nuclear fusion, the engine that drives our Sun and sustains life on Earth.